Welcome back to this channel. Let's look at this question together. Solution. One time we first want you to have knowledge about in this aspect of calculus is how to differentiate whenever you're having sign. What are you going to have? Have your four cardinal points like this. We have sine, we have cos, we have minus sine, and we have minus cos. If you differentiate sine, you are going to get this cos. If you differentiate cos, you are going to get negative sign. If you differentiate negative sign, you are going to get this. And if you differentiate this, so this is differentiation. So this is the expression that we are given. Very first thing is at x is equals to 0. Let's check. Maybe we are going to get our final answer. At x is equals to 0. Just input these values, input it inside this place. So we are going to have sine of 0 minus 0 divided by 0 raised to power 3, which is equals to sine of 0 will give us 0. So we have 0 minus 0, that is 0 divided by 0. And that simply means this expression is undefined. So whenever we are having something like this, what are we going to do? You can't just leave your answer like this and say, okay, you are done with your answer. No, you have to make sure that the given fraction that you get is a fraction that is divine. If the fraction is divine, in the sense that the value you are going to have in your denominator must not be 0. No, anything divided by 0, that is what makes the fraction undivine. So what are we going to use? We are going to apply one rule that is called L'Hopital's rule. Let's check. Apply L'Hopital's rule. And what did this rule tell us? It tells us that we are going to differentiate any given limit. We are going to differentiate it. After differentiating it, we now take the limit at that given value, which is as x tends to 0. So we have d with respect to x of sine x minus x. This one is going to give us differentiate sine, we are going to get cos. So we have cos x minus, if we differentiate ordinary x, we are going to have 1. Let's differentiate the denominator. So we have d dx of x cubed, which is going to give us 3x squared. This will be your new numerator, this will be your new denominator. At x is equals to 0. So we put it back. We have cos x minus 1 all over 3x squared, which is equals to cos 0 minus 1 divided by 3 into 0 squared. We check this very well. This cos 0 will give us 1, and that is 1 minus 1 divided by this will give us 0, which is equal to 0 divided by 0. Undefined again. You are still going to apply the same L'Hopital's rule again and again until you are able to figure out this 0. We do not have 0 again here. Applying the L'Hopital's rule on these ones now, that is d dx of cos x minus 1. If you take the differentiation of cos x, just look at this place. Cos x is going to give us minus sine. So we have minus sine x. Then differentiation of 1 with respect to x, that will give us 0 minus 0. Denominator 2, we are going to differentiate it again. d dx of 3x squared. So what are we going to have here? These two will come to the front. It's going to multiply 3. We have x raised to power 2 minus 1, which is equals to what? 6x raised to power 1. From the given expression, we are going to replace this to this and this to be this. At x is equals to 0 sine x divided by 6x. This is going to give us minus sine, that is 0 divided by 6 into 0. So we still have minus sine 0 will give us minus 0 divided by 0. Equals to 0 divided by 0 will be undefined. Does it mean now that you are going to stop here? No. The principle is whenever you are taking any limit of a given expression at a given value, which is x tends to this value, you must make sure you do not have 0 in your denominator. We are going to apply the L'Hopital's rule again. If you apply it, we are not going to apply it on this one and this one. Let's see what we are going to have. d dx of minus sine x is going to give us what? If you differentiate sine minus sine, which is this, what are you going to have? It's going to give us minus cos. So we have minus cos x. And if you differentiate this, d dx of this x, which is equals to ordinary 6, at x is equals to 0. Let's check. This will now be our new numerator, this will now be our new denominator. We are going to have minus cos x divided by 6, which is equals to minus cos 0 divided by 6. Normal, cos 0 will give us 1. So we have minus 1 divided by 3. One thing is, make sure that your denominator here is not 0. It's not 0. So you continue to apply the L'Hopital's rule until you get to the point that you are now having your denominator 0. Thank you very much.